Hello, hi everyone. So welcome back to my channel and let's start with today's Leetcode challenge 2684, that is maximum number of moves in a grid. So till now we have completed 16 to 17 challenges, and in case you have missed any, you can watch it on my YouTube channel. I've created a playlist for the same. So let's just quickly start the today's problem statement. So we are given a zero indexed m cross n matrix grid consisting of positive integers, and we can start from any cell in the first column, okay, and traverse the grid in the following way. From a cell row column, you can move to any of the cell, that is row minus 1, column plus 1, row column plus 1, and row plus 1, column plus 1, such that the value of the cell you move to should be strictly bigger than the value of the current cell. And now we have to return the maximum number of moves that we can perform. Okay, so if you see that in this example we have 2, 5, 3, 10. So we will start from 2, then we will jump to 3 directions we can jump. Okay, so above one, the same one in the next column, and the below one diagonally, right? So we will jump to 4, then we will jump to 9, and then we will jump to 11. So total we have taken 3 steps. Okay, 1, 2, and 3. So the answer is 3, right? And similar, if you see in this example, so you cannot move to any of the next direction as per the given constraint, because if you start from 1, the next value will be 1 or 1. You cannot jump on any of them because they will be like equal, not greater. Similarly for 2, similarly for 3. So you cannot start, so you will just return 0, right? So we will move quickly to the intuition part, right? So we can start with the intuition building part. So as we are given in the example, what is the path? So it is from 2 we will start, and then we will go to this 4, then we will go to 9, then we can go to 11. So the path was, you can write it here, 2, 4, 9, 11, right? It can be 3, then 9, then 13, then 15. It can be this one also, right? Because if you see that we can start from 3, then we can go to the greater, and in 3 directions we can go, in this, in this, and this. So only 3 directions are possible for every position that we can go. So for 3, these 3 are possible. For 2, these 2 are all only possible. For 5, these 3 are possible. For 10, only this are possible, right? So for 3, if we start from 4, we cannot go. For, okay, we can go, sorry. So for 4 we can go, then we can go to 9, right? It is greater. Then 11, it is greater. So at max, how many steps we are doing? So 1 step, 2 step, then 3 step. So right. So at max, the answer that we are returning is 3 only, right? It can be 2, 4, 9, 11. It can be, we cannot start from 4, oh sorry, 5, because we don't have any greater element on its right in these 3 directions. Okay, but for 3 we have. So for 3, how will it go? So 3, 4, 9, and 11. Okay, or it can be 3, 9, 13, 15, or one possible also 3, 4, 13, 15. So either way it can go, 2, 4, 9, 11, either this 2, 4, 9, 11, or for this 3, this 4, this 9, this 11, or this 4, this 9, this 11, or this 9, this 13, this, sorry, 15. Okay, so multiple paths are possible, and the maximum answer that we are getting is 3 only, right? So now how we should proceed? So if you see that directly, we can start from here, and constraint is the next current value should be less than next value, right? So current value that you are on is 2, and the next value should be greater. So how you can pick it? You will try to go for each value. You will start from here 2. You try going to this 4. Is it possible? Yes. So you will go to this 4, right? Now for this 4, you will try to go on which positions? This, and this, but this is not possible. So you will go to this and this. this is also not possible because the value is smaller, so you will go to here. Okay, now you jump to here and your count is currently 2. Earlier your count is 1. Now for this 9, which 3 positions are available? This and this. So you try going here, not possible. You try going here, not possible. But this is possible. So you will jump to here, right? Your current step count is 3. Now from this, no, nothing is possible because this is the last column. So after this, you will just get your answer. Now, if you see, you will start for 5. So you try going for here, here, here. Now, since all of these are not possible because they are smaller, so what you will do? You will just exit for this. Now you will, okay, so one we have missed for 2. So for 2, you jump from only on this position, but you can jump on this, right? Because this is also greater. So you try jumping here and your count was 1. Now from this 4, you can jump to either of 3, 9, 2, but 9 is only possible. So you will jump here and your current count is 2. So I will rub this and we have your answer as maximum 3. Now from this 9 where you can jump these 3 and only 11 was possible. So you will jump and update your count. Now for 2 you have discovered 2 paths, this and this. Okay, so this 4, then this 9 and this 11. So 2 paths we have discovered and both the paths are giving maximum 3 answer. So you will just keep your answer. Now we will try for 5. Nothing is possible, so you will not go. Okay, for 3 you will try. So you will try going this position and this. All of are possible. First go here, right above 1. Now from here, how many paths you can go? 3, and only 9 was possible. So you will go to 9 and from 9, 11 is possible. So you have got this path and your step was also 3, right? So 3 steps are possible for this path. This and this, right? Now for this path, this 4, now this 4 can go to this 9 and this 11, right? So for this path, this 4, this 9, this 11, you're also getting 3. So this is also possible. Now with this 4 only, you can either go to 9, either go to 13. 2 is not possible because it is smaller. So you will try going here, and from this 13 you can go to this 15 because 11 is not possible and this is also not possible. This is out of range and this is smaller. So 15. So 3, 9, 13, 14 is possible, right? Sorry, 3, 9. Okay, 3, 4, 13, 15 is possible. So it is also giving you 3, right? So what we are seeing that there can be multiple paths, first thing, and we just have to return the steps, number of steps. And one major thing that we are seeing, right, that we will discuss later how we will be solving. So that from this 4, if you are seeing this 4, how many paths are possible? Only this, right? So how many steps are possible to go till the end? 2, right? And you can reach till the end and maximum you will get 2 steps. Okay, and from this 4, if you are seeing, this can go only to this and this, right? So every time, if for this, let's just say for this 10, you have somewhere again 2, right? So for this 2, you can either go to both of these positions. And now from this 4, how many paths are possible? These 2, and they will lead to this 4, 9, 11, 13, 15. Okay, so they both are giving you 2 answer. So you are going to multiple positions many times. This 4 you are encountering one time, but this 4 you are encountering 2 times from this 2, right? And this 3, and this 4 is encountered multiple times, like for this 3 and this 2. Okay, and this 9 is also encountered multiple times because for this 2 you are going, as you are seeing, this 2 times. So this here and this here. Okay, And now also the 4 this 4 is also encountered 2 times. So if possible, if you can, for this 4 you can store number of possible ways to go. If you can store, because this is maximum how many paths it can go, steps it can go maximum 2, right? And at the very step, if this is possible, then it can max go to 2. So the answer can be 2 plus one step is your 3 1, so that is giving you 3, right? So I think we will be using the same approach. Okay, but first, this, as you are seeing, for every value of this we are checking if possible or not going till the end. So this is directly a recursion approach, okay, recursive approach. So we will go like that in this and try getting our answer. So I will write the pseudocode first, and then we will try to check how we can use this, store the number of possible ways. So the recursive approach will be pseudocode. Okay, now the recursive approach, what we have, let's just say we have a solve function, okay, that will have a grid, that is currently this grid, right? Or I will do the dry run on this. So grid and your current row, current column, and your current value, right? And your, what is the range? So that will be, let's just say n and m. N is the number of rows and m is the number of columns, right? So this you will have. So how you will do it? First, you will find your upper value, then your middle value, then your lower value, right? So you have to find 3 values. So let's just say int upper, I will try initializing them to 0, upper, lower, and middle, right? You will try going upper. So what is the constraint? That this upper should be in the range of 0 till this. So you will check first if your current row you are only this. So for this, how you will check? So current row minus 1 should be greater than 0, right? Then only you can go to upper value. And what you have to check, your column should be, if you're going to this column, let's just say for 5, you cannot go here, right? Because it will be out of your row and column. So you have to check for column. So current column plus 1, because you have to go for next, current column plus 1 should be less than your m. So this, and one more constraint that we have to check, the value. So what you will do, you will directly check that your current value should be smaller than your grid of current row minus 1 and current column plus 1, right? If this, all these conditions are true, then you can go to upper value, right? So now you will get your upper value is equals to, your upper value will be one step you can go, right? So one step plus, now this will find your, you will call again this method solve and try searching for the number of steps from this position till the last where you have to go. So you will pass the grid again, right? Current row will be your minus 1, right? Updating that, current column will be plus 1, and your value, okay, so current value now will be grid of current row minus 1 and current column plus 1. This is the current value, and your nm will be same, right? So this will give you number of steps from this position, let's just say for 3, this position, right? From 4 till the end, how many steps you will get. So this will get you, plus you can go to this 4, so it will give you 1. So you are getting that up value, okay? So from this to this, it will update you. Similarly, if now this is your upper position, right? Now similarly you will check for same row column. Okay, so now we will go for this same row thing. Okay, so we will go for now the same column. Okay, for same, do you need to check for this row? I don't think, because you're currently on a valid row and this will also be a valid row. So you just have to check for the column, because if you are on this, you cannot go for this column, right? Now you just have to check your column. So current column plus 1 should be greater, so should be less than your maximum columns, right? And similar check for value. So current value should be less than your grid of current row and current column plus 1, right? If this is possible, then you can go for middle. Middle will be similar. One step you can go and you will find for this, from this position till the last, you will get your answer from your function. You will pass the grid, same row. Okay, row will be same, column will be updated, value will be grid of current row and current column plus 1, and your n and m. Now, so now we will check for bottom one. How we'll check? We'll check for that row should not be exceeding the maximum row. Now, row plus 1 should be less than your maximum rows, and column plus 1 should be same, less than your maximum column, and same value check, that your current value should be less than your grid of row plus 1 and your column plus 1, right? If this is true, then you can update your bottom. Okay, so we have this as low, so low will be equals to 1 plus. Now you again go for your same function and you will do like grid, and now you will pass the row, that is plus 1, column plus 1, and current value will be grid of current row plus 1 and current column plus 1, number of rows and number of columns, right? So now you have all these values, up, middle and low you have. And now what you have to return, if you check in your example, it is mentioned in the question that you have to return maximum, right? Maximum answer. So now for what you will return maximum of up and maximum of low and middle, right? So this is how you will get your maximum and this will get your result. Now before, because yes, you are checking, but there's one base case. So when you will reach here, you don't have to go again up, down and bottom. You can directly check here that if this is the last position. So how you can check your base case, right? Because in general recursion, you try getting your answer like this and you have one of your base case. So it is, you can directly check your current column plus 1. If it is greater than m, then you can directly return 0, because beyond this you cannot go. So the number of step will be 0, right? So you can directly return 0. So this will help you, like this is a recursive solution, pseudocode, and we can go the small try run. And one thing, that this solution will give time limit exceeded on this problem. So I will do that optimization in while coding so that you can understand better. But this is the main logic and code that you need to review and build. So small try run if we do. So now we will start from this. So there's one somewhere your function. So let's just say there's some function, and from there you will go for I 0 till n, right? That we are correct. So for each value, let's get the current value is grid of, this is row, so grid of I, and we have to start from 0th column. And now for every this, let's just say we have our answer currently 0, and every time we will update our answer like this, answer of max of the current answer, and you will call your function solve with your grid. Current row will be like this I, right? Column we are starting from 0, and what you need, that current value. So you have your current value, and maximum it will be nm, right? So this is how you will start with your initial function, right? And you have got your answer, so you will directly return it, return answer. This is a function part, and this is the main solution. Okay, now the small dry run will be, you will go to each of this column, each of these values in the this multiple rows in a column using this loop, right? And now when you come to 2, you will check for upper, can you go? No, so you will not go. But then you will come to this middle, right? With middle, yes, you can go. And with 4, you try getting your answer going till recursion, right? So this recursive solution will get your answer as 2, right? And plus 1 is 3, so middle value currently is 3, right? Now it will go to low. For this low, it will try finding for this 4, and with this 4 you can go to this 9 and 11. So similar value will be 2. 2 plus 1, 3, right? This is also 3. So now you, when you return, so maximum of 0, 3, 3. So it will be 3 finally. And for this 2, you will get your answer here as 3, and your answer will become 3. Now you will try finding for all of them 5, 3, 10, similar approach, and it will get your answer, right? So now we will code this solution, and after that, at that point only, we will discuss the time complexity and the optimization, because we see that this logic optimization, because we already see that this logic is encountering multiple values, sorry, each value multiple times in these columns, right? Except for the one in these columns, these values are encountered multiple times. So that is already increasing our time complexity, and we have to optimize it. So how we will optimize? Using some storage. So if you know, before going to this 4, if you already know that from this 4 till the end, how many steps you require, so you can directly return it instead of going to this recursive solution, recursive function, and finding it. You can directly return it, because once you encountered this 4 or this 4, right, from 2 this 4 is encountered and this 4 is encountered. When you start from this 3, you try encountering this 4, and again you try to find your this solution is similar, 2 steps. So if you know that you can directly give 3 as your answer, so that is an optimization that we do, and I will tell you during the coding part. Okay, so we can quickly start our solution part. So first we have our number of rows, so grid dot size, and column will be grid 0 dot size, right? Now we have our answer as 0 currently. We will go for each these rows for the first. So it's 0 till row I plus plus, and now we will get our current value. Current value will be grid of I 0, and answer will be updated like this. So max of answer, and we will create a function solve that will take our grid, right? Current row is I, column is 0, and current value, and your maximum row and maximum column. Okay, now after that we will return our answer. So this is a small logic. Now we will create our function. So int solve, and it will take first this grid, right? And it will take a current row and current column, and int current value, and your max row, so max row and max column, right? These all values will be get. Now how we will do? First, int upper will be 0, lower will be 0, and middle will be 0. We'll assign it. Now first check for upper value, right? If your current row -1, so upper will be -1, it should be less than, okay, sorry, it should be greater than equal to 0, right? It should not, it should be greater than equal to 0. And column check is same, column +1 should be less than your max column, because max column is this, right? Because the column is 4, if you see, so 0, 1, 2, 3, 4, so 4 will be here, so it should not reach here, right? So column +1 should be less than your max column. And last check is the value check that we have to, this is strictly bigger, so now we will check current value should be less than your grid of current row -1, current column +1. If all these checks are successful, then we will update our upper value as one step we can go, and we will try getting our answer from our function from this position, okay, from the above position till the last. So we will pass our grid again, and current row will be updated with -1, current column will be updated with +1, and current value will be changed, so it will be this, right? And max row will be same, max column will be same, right? Now we will do similar check for lower, okay, lower value. So for lower, if your current row +1 should be not exceeding the maximum row, so it should be less than max row, and same column check should be same because it should not go out of bound, so it should be right. And value should be, current value should be less than your grid current row +1 and current column +1. If this is true, then we will get our lower value. Lower will be 1 plus the function will get our answer from this position. It is for 3, we can go to 9, and from this position till the last, this function will get grid current row +1, current column +1, and our current value will be grid of current row +1, current column +1. So this will get our value, and max row max column will be same. Okay, now we will check for middle. So if you see for middle, do we have to check for the row? Because the row is same, so we don't have to check for the row, we can directly check for columns. Column +1 should be in our range of this max column, okay, and directly check for our value. So value check will be like this, row should be same, okay. If this is possible, then we will update our middle. So middle will be equals to 1 plus solve and grid, okay. Row will be same, column will be updated, value will be current row current column +1, max row and max column, right? And after that, what you have to return? The maximum of all three. So maximum of your upper and maximum of lower middle. So yeah, this is how you can calculate. Okay, so I don't think that there is any need, but if anyone wants, then they can check for base case, but there's no need because we are doing checks every time before going after. So at this position, we are doing the check. So there's no point that we will go beyond this or beyond this row or beyond this row, last row or first row beyond. So there's no point. So I will not do it, right? But if anyone wants, they can check beforehand, that is okay. So now we will try running this code. Okay, so it is passing these test cases. Now we will try to submit it, and now we will check. Okay, so as we have expected, time limit exceeded as we have discussed, because it is going to like this position is encountered multiple times. Similarly, this Okay, this position is encountered multiple times, similarly this, right? So from this, if we have known that going to the last is almost maximum one step, so we can directly return it. So what we'll do, we will do a memoization. So first we will create our memory. So memory will be vector of, that will create a 2D vector, right? 2D, because this is a 2D matrix, so we'll create a DP of the same size, row and column, and we will initialize all of them with -1 currently. Now I will just pass it here and add one parameter. So vector of DP, right? And now before, before, because this will be called recursively, so before going here I can directly check if this position is encountered previously, right? So if DP of current row and current column that we are currently on, if this is encountered before, if it is not equal to -1, then we can directly return DP of current row and current column, right? If it is not, that means for current row and column we will have to update. So this is we are returning, so here we will update DP of current row and current column, right? Because from this position we are calculating the maximum answer that we can get going till end. So if we have this answer beforehand, we can directly return it here, and if we not, then we can directly update it here, right? Now we'll try to run it. Okay, so there's some error. Okay, where it is. Okay, so we are not passing this DP here. We have to pass, right? Okay, so it is running fine for these. Let's just try to submit it. Okay, yes. So we have submitted this successfully. So thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notification so that we can solve these daily challenges together. And if you have any questions or any doubts, you can ask in the comment section. Or if you have any alternate approach, you can share that in the comments. We'll review it and share it with everyone so that everyone should be aware.